just to give you a conceptual idea of it, have you ever been out in the cold and you didn't have gloves and your hands are cold and you rub your hands together to warm them up? Who's ever done that? Yeah. And why does that warm your hands up?
Friction.
Friction. And what happens is, friction, you're doing work against friction, and that work is being converted into what we call heat, or actually it's more strictly called internal energy. So it turns out there is a mathematical equivalence, and what we're going to look at today is the mathematical equivalence between doing work against friction and heating up water. So I don't know how many working setups we have, but if you're partnerless, you may want to join forces with another group and have a group of 3. Now, here's what you're going to need to collect. First of all, at your lab station, you'll find 5 kilogram set of masses, and an apparatus that looks, it's got some sort of hand crank on it. And then it's got these little peg holes in it that, if you've ever played cribbage, kind of remind me of the holes that you put the pegs in cribbage. So that's what'll be at your table. And you're going to need a funnel, but I think we only have 2 of them in the back, so you're going to have to share. You'll want a graduated cylinder. You need a thermometer. And you need this copper drum. You should try to keep skin oil off the center part of the cylinder. You can see it looks kind of shiny there. I'm not sure it makes that much difference, but it does say to keep skin oil off it. And if it doesn't look very shiny, there's a little piece of emery paper in your, that's the other thing, I'm sorry. You have to get the the copper drum, a container of little bits and pieces, and a thermometer, and the graduated cylinder from the back. And if this is not shiny enough, you can polish it up a bit with the emery paper, but I don't view that as a critical part of the operation. Now, there's going to be this piece of copper braid, this braided wire, and be careful, because this stuff is frayed, and I've gotten many a metal splinter from these braids, so just be careful. And they're smart, because they break off and they're just like under your skin. You can't grab them and get them out very easily. So that's the big danger here. Well, that and dropping 5 kilograms on your toe, I suppose, is a pretty big danger. All right, this little piece is called a ferrule, F-E-R-U-L-E, I think it's listed as in your book. And it's like the lid to the little copper drum. Oh. Which doesn't seem to want to, it's threaded, but I'm having trouble threading it on there. Hang on, you'll also find a rubber washer, or it might be a grommet, and a metal washer. So the rubber washer is to help you get, not just to get a good seal, but you're going to end up putting the thermometer through the ferrule and then put it on there. So that's what's going on with the rubber thing grips that. And now it should, once you've got all the washers in place, then it screws on, okay? So you're going to end up with a setup like this. But before you do that, and I'm going to recommend that you actually thread the thermometer into the little rubber think it's a grommet more than a washer, into the rubber grommet before you try to put it on here. And just be careful that you don't, I mean, it's the end of semester, everybody's tired, and maybe you're not being real mindful of what you're doing. I just don't want anybody to be shoving the thermometer into this little apparatus and then snap it in half and, you know, jam it in your hand. There's potential for all kinds of injuries in here. Do I sound like a mother? Okay. Now, if you look at the data page, there's like a table here. And it says to put in a mass of water of 7/700ths of a kilogram, which is 70 grams. Now listen to me. I think I told you in lecture that the density of water, remember that's a rho, is 1 gram per cubic centimeter. Did I tell you that? One of the first things my high school chemistry teacher wrote on the board, and I've remembered ever since, is that 1 gram of water has a volume of 1 cubic centimeter or 1 milliliter. Okay? The density of water is 1. So rather than mass this little container and then try to put 70 grams of water in the container, you know, remassing it, use this graduated cylinder, measure out 50 milliliters of water. That would be how many grams? 50. And then another 20, and then use the funnel to pour those in here. Okay, so you're going to pour 70 milliliters of water. I think the instructions may tell you to be massing stuff. You will need to mass this, but you don't need to mass the water. You can just get it from its volume. All right, so you will need to mass this. Okay, you also need, and perhaps I will help you here. You will also need the diameter of the drum. Can't get this open. There we go. Okay, so you're going to use the vernier caliper. We've used them several times now. And I'm going to say that you ought to get something like 4.648 centimeters. That's what I'm getting. Yours may vary a little bit. That's the diameter of the drum. And you'll, of course, need that in meters. So what would that be in meters? Thank you. 0.04648 meters. And let's see, is that the only diameter measurement we need? I think that's all we need with this. So go ahead and use the vernier caliper, the dial caliper. You want one that's got a dial on it, to measure the diameter of the drum. And just know that it ought to be pretty close to 4.6 centimeters. Okay, so you need the mass of the drum and the mass of this little copper piece. And I already told you the mass of the water. There's that, the fourth line down says mass of water equivalent. What they've done is they've figured out the thermometer is effectively like having that additional water. So you're just going to add 0.0008 kilograms in. It's like to account for the thermometer. And let's see. Okay, you're going to need the initial temperature and the final temperature, and here I am just hanging on to the bottom of that thermometer. I shouldn't be. I don't believe it's that hot. Okay, we need room temperature, which I'm going to say ought to be about 25 or 26. Would you pause that? I'm going to just run to the